I was at an auction a few weeks ago. First real good auction I've been to in a number of years. They had some real bargains there. It was a welding shop that was closing up. The gentleman had retired and he was getting rid of everything. He had a lot of stuff. And there were tools, not just welding tools, but some woodworking tools and bandsaws. It was a great auction. And I saw a lot of people getting excited about a bunch of items, but I think there may have been some disappointments too, because you need to know something about electricity when you're buying tools. Hello, my name's Roger Kugler. This is Working at Woodworking Podcast, where I hope to give you information and encouragement for you to start your own woodworking business. We have precious few craftsmen in this country now. Most of them have aged out. They've either retired or they've passed away in their shops, still with jobs undone. We need people to step up and replace those craftsmen. So today we're going to talk about electricity in your woodworking shop, episode number 41. Now, disclaimer, number one, I am not an electrician. And I'm going to say some things in here that will probably raise the blood pressure of some of you professional electricians who might happen to be listening to this show. I have the utmost respect for licensed electricians. It is a great profession. In fact, we need a lot more good electricians. So if you've been thinking about that, I would highly encourage you to check that out. So anyway, I am not an electrician, but I have done a lot of my own electrical work. So today I want to talk about some of the basics, hopefully to pass on a basic understanding of electricity, particularly when it comes to power tools. So we know that power is generated at some power generation plant. A lot of times that's coal, natural gas, nuclear, some solar, and wind. So that power is generated, but it has to get distributed throughout the country, and that's where the power grid comes in. Now, the most efficient way to generate electricity is to step up the voltage very, very, very high, like hundreds of thousands of volts in the transmission line. If you go out into your backyard and you look at the power pole, the higher the wires are, the more dangerous they are. So probably the very lowest wire is your video, telephone, cable. Then above that, you'll have some other wires, but at the very, very top, you'll have a bare copper wire. That is what's carrying the electricity. And that is an uninsulated wire. That's what makes it so dangerous. They put it at the very top of the power pole where it's less likely to interfere with anything. That's why in a storm, if power poles get knocked down and there's a wire laying on the ground, you have to treat that as a live wire unless someone tells you that it's not. Anyway, so you have this very high voltage line being transmitting electricity from the power plant to a station and from the station to the substation. Each time it gets stepped down in voltage a little bit until finally it gets to your street and it comes up through your backyard or maybe your front yard or maybe underground, and it hits another transformer that further steps that voltage down to something that we mere mortals can use, 120 volts. Now, that was a really poor explanation of our power grid, power generation system in the U.S. If you want to hear a professional give you an explanation, you need to check out Grady at Practical Engineering on YouTube. How does the power grid work? I've left a link to the video in the show notes. It's a great video. He's an incredibly knowledgeable and communicative guy. I love watching his videos. Now, before we go too much further, we need to understand some terms. That means it's time for Define That Word. Okay, so what is a volt? A volt is a unit of voltage. Voltage is the pressure of that current moving through the power line. Now, I'm using the water analogy here, and I know that all of you professional electricians out there are just cringing at the moment and probably shouting expletives at me. I understand, but remember, feeble minds think simply. So this is the best I can do. You have electricity flowing from the power generation plant to your electrical outlet. The pressure, measured in volts, tells us how much potential there is in that power line. So if you have a garden hose that you just crack just ever so slightly and the water kind of trickles out, well, there's not a whole lot of potential there. It's going to take you a long time to wash your car. But if you open that valve all the way, now the water is blasting out of the hose, and it's not going to take very long to wash your car with that because there's more pressure. So think of electricity kind of in that same terms, but just understand that theoretically it's incorrect. But anyway, it will work for our illustrations. Now there's two types of electricity. There's AC and there's DC. AC, or alternating current, kind of think about the current moving forward and then suddenly backwards and forward and backwards and forward and backwards. And let's just leave it at that. Direct current, or DC current, is what we would find in a flashlight. There's a battery, there's a bulb, there's wires or metal connecting everything together, and when you turn on the switch, the bulb lights up because it completes the circuit from the battery to the bulb to the switch back to the battery. It is a direct current. It's flowing only in one direction. And DC current's used in a whole bunch of stuff. Electronics, namely, mostly are DC currents. Automobiles are using DC currents. DC current is wonderful for short-range power transmission. The problem is that if we generated electricity and converted it to DC at the power generation station, we couldn't really transport it over, hundreds of miles. It's just not efficient to do it that way, unless you're Tesla. If you need a distraction sometime, look up Tesla and the Edison lawsuits and debates, and you'll get an idea of how we formed our power generation in the United States back in the late 1800s, early 1900s. Fascinating story. I digress. And there's also another type is AC/DC. Now, that is a rock band that was formed from two chaps in New South Wales. They were both Scottish-born brothers, Malcolm and Angus Young, and produced some of the very, very best, rock, heavy metal music. Classics like Back in Black and You Shook Me All Night Long, and my personal favorite, Thunderstruck. So if people are talking about AC/DC, it might be the rock band and not a discussion on electrical principles. Then we come to phase. Power can be generated or used in two different phases. There's single phase and there's three phase. This gets a little tricky, but if we think about a motor, and most motors that you come in contact in your life are single phase, there's one wire coming into that motor, and it makes the motor operate. A three-phase motor has three lines coming into the motor, and it makes it operate much more powerfully and much more efficiently. We'll talk a little bit more about that later. And there's also frequency. Starting to get a little deep in a rabbit hole, but frequency is basically the cycles per second of the electricity traveling through that electrical line. In the U.S., we use 60 hertz. Hertz is a measurement of frequency. In other parts of the world, they use 50 hertz, and I think there's even variations from that. Don't worry about that. If you see 60Hz, that's what they're referring to, is the frequency of the motor. So what does this have to do with your shop? What do you have in your shop? Well, unless it was specifically built, you probably have 120 VAC, volts alternating current, single phase, one line, 60 hertz line power. What type of tools do you have in your shop? Well, you probably have 120 VAC, single phase, 60 hertz, which generally will give you about 1.5 horsepower of power. You could put a 1.5 horse motor in there and it would work perfectly fine. But what tools would you like to have in your shop? Yeah, I know. You've been thinking about a saw stop, haven't you? Great saws, great safety feature. And you just happened to notice on one online store, they have a saw stop PCS series, 3-horse, single-phase, professional cabinet saw with the 52-inch T-Track glide fence. $3,600. A lot of money, a lot of saw. It has the patented safety system. It claims 99% dust collection system. It has a fast blade height adjustment, easy reach start and stop switch, and a 4-inch dust port. And as you read the description further, you get into all the dimensions of the saw and the height above ground of the table and the overall dimensions. And all these things are very important, to see if this will actually fit into your shop. And if you go to the SawStop webpage and you look up that same saw, the PCS model number 31230, 3-horse, single-phase, 230-volt, 13 amp. And if you read down through the specs, you see that it comes with a NEMA 615P 9-foot cord. Whoa. There's a lot more information here on SawStop's webpage than the online retailer's webpage. Highly encourage you to always check the source for the most accurate data. The website owner, the online store owner, is just putting up the information that he thinks most people would be interested in, not getting into the details. But they left out a very important detail, 230 volt. Bottom dollar, I bet you don't have 230 volts in your woodworking shop unless it was purposely built for that. You do have 230 volts electrical service in your home, especially if you have an electric oven and range top. They require a lot of power. If you have an electric dryer, you have a 230 volt service because they draw a lot of power. But most garages, no, they aren't wired for 230. Why would they? Well, nowadays, with the increased interest in electric vehicles, more and more garages are being wired with 230 because that's a more efficient way to recharge your electric vehicle. And in some cases, people are installing 440 volt service. So let's break this down a little bit more. It says a 3 horsepower. What exactly is a horsepower? Well, back in the good old days, like 300 years ago at the start of the Industrial Revolution, they calculated the horsepower as the amount of weight a horse could lift 1 foot in 1 second. And that came out to be 550 pounds. So they tied a rope onto a horse, led that up to a pulley, and then a pulley down to a weight. And a horse had to be able to walk forward, pulling that weight up 1 foot in 1 second. So there's this time factor in here. It's kind of like acceleration. Distance over time is how we refer to power. And a 3 horsepower is a lot more powerful than a 1.5 horsepower that you would typically get out of a 120 volt service. Understand? Because literally, there are 2 wires coming from your transformer, the step-down transformer sitting out back in your yard that brings the 2 lines into your house. I'm in a house that was built, 60, 70 years ago, and so mine's above ground, and I can walk out and I can see these 2 really thick wires that are kind of coiled together, twisted together, coming into my service box. Most new homes, all of that is buried underground, and so you never see it. So if one wire carries 120 volts, if you have two of them, now you have 240 volts. So why the difference between 230 and 240? It's kind of a math thing, and I don't fully understand it. Sometimes you'll even hear it referred to as 220 volt. So generally, let's say there's 120 volts and there's 240 volts. Now, if we go through a little bit more, we see that it's a single phase motor on a saw stop. That's a good thing. We have single phase power service to our home or our shop. And then it drops down and it says 13 amps. What in the heck is an amp? Let's equate an amp or amperage to current flow. It's fast moving current. Okay, all you electricians out there, send your hate mail to roger@workingatwoodworking.com. I'll read them. I will accept it. If you want to throw an explanation in there, please do so. But for our illustrations, we're going to stay with the current. So if you walk out to a stream and it's the middle of summer and the water's just barely moving, is barely trickling through, that has very low current. The water is not moving very fast. If you visit the stream in the spring, after we've had some heavy rains and snow melt, that water is moving. There is fast current. And so that's what we're measuring amperage. Amperage is the potential of current flow between the transmission pole and your device. And you use an amp meter to determine how many amps that particular machine is drawing. We get the word amperage from the French mathematician and physicist André-Marie Ampère. Okay, you can send your hate mail to roger@workingatwoodworking.com because I know that I butchered that name. But it was a really cool French scientist who came up with this concept of how fast current is moving through a wire. Remember, this is all back in like the mid-1700s that they were figuring all this stuff out. It's really pretty fascinating. So, can you buy that saw stop table saw? Yeah, you can buy it, but you're also going to need to call your electrician because they're going to have to come in and install a circuit for 240 volts AC. This is what the motor was designed to run on. Could you plug it into 120? Well, technically no, because that has a NEMA 615P plug, and that's a very specifically shaped electrical plug that you have to have the matching socket to plug that into. If you want to get into NEMA plugs, NEMA is the, oh gosh, it's French. It's a national, international standard of how mechanical things work. It specifies sizes and shapes and dimensions, and I left a link in the show notes to a website that talks about the different NEMA standards. It's actually kind of fun in a bizarre sort of way. But no, if you did wire that table saw up to 120, it would not work very well because you're only drawing 1/2 of the voltage that the saw needs. So it'll turn over, but you're not going to cut anything with it and probably end up damaging the motor. So don't do that. And you notice it was 13 amps or amperes. Now, in your house, most of your sockets, depending on when your house was built, most of your lighting is on a 15 amp circuit. A lot of your receptacles, your wall outlets are on a 20 amp circuit. That means that if you have the toaster, the microwave, the hair dryer, and the curling iron all on the same circuit, you're probably going to blow a breaker. Or if it's a very old house, a fuse. So what determines if you have a 15 amp circuit in your home or a 20 amp circuit in your home? Well, that's really dependent upon wire size. If you were running a lighting circuit, you would use 16 gauge. That's relatively thin, almost a 1/16 of an inch diameter wire. And that was much cheaper than the standard 14 gauge wire that you would use for the 20 amp circuit. But don't get hung up on that. one of the big things whenever you're looking at motors, for different woodworking machineries is the startup power, the draw at startup, because it's very often much larger current demand. It needs more amps at startup than it does during normal running operation. And that's why you need to have a circuit that is large enough that it can handle that extra draw. Manufacturers kind of get around this with this little trick of using a capacitor. Don't want to get too deep here, but a capacitor is basically a short-term storage device, a really short-term battery. It can be charged up, and then that power can be discharged all at once. And we see this on a lot of power tools. My bandsaw has a capacitor, a starting capacitor on the motor that when I hit the switch, that capacitor discharges energy into the motor and helps to kick it over and get it started. And if you listen to a tool like a bandsaw, you'll hear this little clicking sound in there. And what that is a centrifugal switch. The switch is closed so that the capacitor can discharge power into the motor. But once it comes up to operating speed, that centrifugal switch opens up and cuts off the power from the capacitor. And the only reason I mention that is sometimes those switches will go bad and either your bandsaw won't work or you get this really weird clicking sound coming out of it, and you need to have the centrifugal switch checked. If you want to learn more about that, you need to watch some videos by Jeremy Fielding. He's an engineer that really gets into this stuff with motors and electricity and things like that. Link in the show notes about centrifugal switches and why your bandsaw may not be operating. So anyway, let's get back to the auction. You'll see some people going around looking at a tool, and very often there's some rust on it and there's some dirt and some grime. I mean, this tool's been typically sitting there for 5, 10, 25 years and hasn't been used. Doesn't mean that the tool is bad. Look at the wiring. Have the mice found it? Sometimes manufacturers will introduce some substances that are salty, and rodents love to chew on this. It isn't really a problem with tools made a long time ago, but more recently, it has become a problem. In the manufacturing of wiring, they're trying to always find something cheaper, and they switched to an installation type that the rodents just absolutely loved, and cars were not operating because, a frickin' mouse or a groundhog got up under there and chewed all the wiring out of it. Anyway, inspect the wiring, make sure that that's good, and inspect the motor nameplate. Someplace on the motor, there will be a plate that will have numbers engraved into it. And that tells you everything you could possibly ever want to know about the motor. The manufacturer, the model number, the horsepower rating, and most important to you, the phase of the motor. Is it a single phase or a 3-phase? Why is this important? Because probably 99% of all the power tools used by hobbyists or, light professionals, one-man shops, one-woman shops are single phase. Remember, that phase was either one line coming into the motor or 3 lines coming into the motor. A lot of these tools at this auction were 3-phase. So if you bid on one of those tools and you win, you're all excited. Wow, I got this great bandsaw. This is fantastic. It's huge, but this is fantastic. And you get the thing home, which is no easy task because these things are typically very large and very heavy. And you bring it in and you look at the plug and you've never seen anything like this before. You may have just screwed up, my friend, because you bought a 3-phase power tool, but you only have single phase at your home. What can you do? Well, you can call your power company and ask if they can install 3-phase power to your home. Person will look up your address and then start laughing at you. It is very expensive for the power company to install 3-phase power, and they only do it to customers that they know they're going to get a return on their investment. So big companies, that are using big machinery, a lot of electricity, they are more than happy to do that with. Somebody working out of his, backyard shop, probably not. Not going to happen. Or you could purchase and install a phase converter. We're converting the electricity that you have, your single phase, into 3-phase. And there's this box, and there's magic inside. And you flip a switch, and your single phase magic electricity is magically converted to 3-phase magic electricity. Because this is all magic anyway. I mean, we all know that. Who really understands electricity? But that is something you can do. You can do this relatively cheaply or very expensively. Some of these things will start out around $400 or $500, and you can go up from there. I mean, it's not uncommon to spend $10,000 on a phase converter. They come in 2 flavors. There is a rotary phase converter where there's literally like another motor in there that is doing the conversion from single phase to 3-phase, and there's static inverters. And these are literally little boxes that have wires running every which way that does all the magic. Rotary converters are very efficient, or much more efficient, and deliver a lot of power. A static converter is not very efficient from a power standpoint, and is also less expensive. So you literally kind of get what you pay for here. But you really need to call your electrician at this point, because this can be a real money sink. But if you have 3-phase power in your shop, you can buy a lot of 3-phase power tools. And the reason you won that bid for that 3-phase bandsaw was everybody else was smarter than you, and they knew that they couldn't use that piece of machinery because they didn't have, nor did they want to install 3-phase into their shop. But if you have 3-phase in your shop, you can go to an auction. Well, everyone else is, paying $300 for an old Delta bandsaw built in the 50s. Yeah, seriously, that happened. The giant 5-horse, 24-inch bandsaw 3-phase motor sells for $35. Seriously, not making this up. So you can get some incredible tools at very cheap prices if you have 3-phase, but that 3-phase is going to cost you. I don't want anyone to make that mistake. If you're at the auction, probably the most important thing that you can look at on power tools is the phase. Is it single phase or 3-phase? And most of us are using single phase, and that's what we're going to have to shop for. Okay, some other things you need to know about electricity, and this is where things start to get kind of muddy, kind of ugly. There was a lawsuit filed by, I think it was the Federal Trade Commission several years ago, that charged manufacturers, tool manufacturers, of deceptive advertising. Most notably were vacuum manufacturers and air compressor manufacturers. You've seen the ads, a shop vac, 6.5 horsepower vacuum, on sale, $99.95. But wait a minute. Didn't you say earlier in the podcast episode that if you had regular house current at 120 VAC, that could only generate 1.5 horsepower? Yes, listener, that is correct. I did say that, and that is true. So how does the manufacturer say that this is a 6.5 horsepower vacuum whenever you can only get 1.5 horse out of a standard household line? Very perceptive. And the answer is, they kind of didn't tell the entire truth honestly. Not saying they lied, but the marketing department took some liberties. Let's leave it at that. Because we're dealing with air acts differently than other things. And when you get into the calculations of this and that and so on and so forth, horsepower kind of changes, and that's what they were using. If I remember right, the courts found that technically, scientifically, mathematically, they were correct, but you're being deceptive and stop it. And they kind of have, somewhat. And air compressors, oh my gosh, you want to talk about a swamp. If you're shopping for an air compressor, kind of disregard most of the stuff that you read. The CFM, or the static CFM, the SCFM number is really important. And the size of the motor is really important. And when you're buying any power tool, probably the best number you can look at is the amp rating of that power tool, or the amperes. So I had bought some air-dried white oak. Gorgeous stuff. There's a lot of, quarter sawn figured grain in some of this stuff. I'm not sure what I'm going to do with it. But these were pretty much slabs. I mean, they're 14, 18 inch wide. Not like a tabletop slab, but these were big chunks of wood that came from a big tree sawn on like a wood miser. And I needed them to be much smaller, less than 12 inches, so that I could run them through my tiny little planer. So I had to buck these things to width. I thought this is a wonderful job for my Festool TS55 track saw. Nope, it was not a wonderful job for the Festool TS55 track saw. The wood was it varied between 4/4 and 5/4 in thickness, and I'm sorry, that track saw just struggled mightily. And just to get through the first cut, I ended up setting the depth to about half, and I would run through and then have to drop it to full depth and run through, make 2 passes to get through this stuff. Not working well at all. So I ditched that idea. I picked up a chalk line, snapped a straight line on the board, and dug out my old Porter Cable 15 amp circular saw. It just walked right through that white oak. Hardly even bogged down. As long as I kept that thing straight and cutting, it just zipped right through that white oak. Oh my gosh. Why did this really, really expensive, track saw fail so miserably? And that thing's got to be 25 years old at least. Porter Cable circular saw, have no problem with it whatsoever. Well, I thought I knew the answer, but I came in and checked. And I looked up the Festool track saw, and it was rated at 1200 watts. My circular saw is 15 amps. Oh my gosh. Watts. What is a watt? I'm so glad you asked that question. A watt is a unit of power that is attributed to James Watt, the 18th century Scottish scientist, mathematician, builder, engineer extraordinaire. Very interesting guy, born around 1730s or so, educated in Glasgow University, led a very interesting life. He married his cousin. They had 6 children. I guess that's what you did back then. And he was, I really admire him because he was a builder. I mean, he specialized in scientific and engineering instruments. He would build sextants or quadrants and other scientific, measuring devices and things. He was kind of a hands-on guy, and he made improvements to the steam engine that, actually led to the Watt steam engine. Look him up sometime. Very, very, very interesting guy. Anyway, Watt is the person we kind of attribute to developing the horsepower measurement, and we have assigned 745.7 watts of power to 1 horsepower. And that leads us to time for math. No. Okay, this isn't hard. I guarantee. Watts came up with what's now referred to as Watt's Law. And that is a way of explaining the relationship between these electrical terms that we've been talking about. Basically, Watt is equal to the voltage times the amperage. We've been talking about voltage, 120, 230. We've been talking about amps. The saw stop was a 13 amp table saw. So if we take this relationship, watts equals voltage time amperage, we can figure out how many amps is in the Festool track saw. It's 1200 watts divided by basic algebra. 120 volts gives us, anyone? 10 amps. Yes, that's right. So my Festool only has 10 amps of power available to it, where the old Porter cable had 15 amps, much more. And that's why it was able to walk through that white oak where the Festool really bogged down. The TS55, that's a cabinet saw. That's a shop saw. I don't think I would use that on a job, up on a roof, cutting plywood or something like that. That's not what that's made for. Besides, you're going to hit a nail and destroy a $100 saw blade. No, don't do that. Use either Porter cable, which I don't think they even make that anymore, or DeWalt has a 7¼ inch, 15 amp. I think it's like $140, $150, something like that. Really good saw. Corded. Everybody else is going battery. Batteries are great. They're really convenient. You can grab them from your toolbox, go out and cut something. Boom, it's done. But if you need something that you're going to be using all day and you don't want to screw around with batteries, get a corded power tool. They just deliver more power. It's math. It's Watt's law. So if you're in the market for power tools and you're at the store, you're looking at different things, look at the motor information plate. It's on there someplace. It's going to tell you it's 120 volt AC, 60 hertz, 12 amps. That is how much power is coming out of that tool. Now, does that mean that a random orbit sander that is 3.4 amps will do a better job than a random orbit sander that is 1.9 amps? Probably, but not necessarily always, because then we get into the tool design and how all the mechanics works and so on and so forth. But generally, if you're comparing two exact tools, the one with a higher amperage is going to deliver more power. And we all know, power is where it's at when it comes to power tools. I know this is a lot. If you knew nothing about electricity, you may still know nothing about electricity. I hope you gleaned something from this rant. Electricity is a fascinating, weird subject, and I would highly encourage you to watch some of the videos that I mentioned, links in the show notes. Take these in little baby steps. Learn one little thing and let that sink in, and then learn something else. Do some reading. There's some excellent books on electricity. There is a difference between studying electricity and electronics. Electronics are the things in your cell phone, in your computer. Electricity is things in your workshop. Yes, they are very related, but it's kind of like almost two different languages. Don't get them confused. And by all means, talk to an electrician. If you're stopped at a stoplight someplace and, there's Bub's Electrical Service there, roll down your window and say hi and ask them about voltage drop in electrical extension cords. You'll have a fascinating, now you probably won't because the light will change and somebody will have to move. Anyway, find an electrician, bend his ear a little bit, buy him a cup of coffee, and think about three-phase power for your shop. It's doable, especially if you're building a new shop. That could be a very wise decision to have that installed. I want to do a special shout out to Zach, who bought me 3 cups of coffee. Very much appreciate that. Thanks a lot. He wrote a very nice show. I'm not quite at the point in my life where I can jump ship, but it has motivated me to finish up a rocking chair and enter it into the county fair. I really liked your furniture repair episodes. This is something I would like to work toward. I would probably also listen to an episode on sawtooth geometry. Cheers. Okay, Zach, you asked for it. I will start working on a sawtooth geometry episode. That should be really interesting. Missed jobs for the week. I had a lady call about building some bifold doors. Don't let the term bifold, throw you off. It's really 4 doors instead of 1 or 2. And you just throw a special hinge in between, and they're not terribly hard. Of course, I had to pass because I have been very distracted and have not gotten as much work done as I should be getting done, and I politely turned her down. So if you gain some value out of this podcast, I would encourage you to mention it to a friend who might be at a point of life where things aren't really going so well in that corporate CEO job, or maybe that law practice is really starting to wear on them, or the hours working at as a beautician is starting to get really old. Maybe it's time for a change. And as always, if anybody would like to buy me a cup of coffee like Zach, I would greatly appreciate it. And be sure to check out the show notes for all of the affiliate links I have in there for Cell Phone Business Service and Skillshare and Taylor Tools. Wonderful company. Been very impressed with them. So until next time, happy woodworking.